So today we are talking about two-way tables. Two-way tables are a great way to organize information. And we can use it to calculate probabilities pretty easily. And so a two-way table is a table that records data from two different categories. And so here we have an example of a two-way table. This two-way table shows the results from a survey in which students were asked their gender and their dominant writing hand, left or right-handed. And so those are the two categories, gender and what hand do you use, okay. And so you notice that we have these male, female, left-handed, right-handed columns, and we have the wraparound total. So what do you suppose we need to do to find the total right here?
Add them up.
Holy mackerel, that's right, 9 and 7 is?
16.
Good. And then 48 and 86 is?
Yeah. 134.
Good, 134, right on. And then, of course, you can also add across to get the total to the right-hand side here. So 7 and 48 is? 55, good. And 9 and 86 is? 95. Now, what's nice here is this total is a good way to double check both directions to make sure you did everything correctly. What is 16 and 34? 150. And then 55 and 95 is also 150. So it checks both directions. It's a good way to double check. All right, so we can create a table pretty easily, and we can also fill in any missing values pretty easily. So let's look at table 2 here. Upon exiting, passengers on a plane were asked if this was their final destination and if they checked any bags. The results are shown in the table. Complete the table by filling in the missing frequency, the missing joint and marginal frequencies. Okay. Joint frequencies are the individual data entries, and the marginal frequencies are the totals of the rows and columns. So anyway, all right, if I know that, let's see, I guess I'm going to add first. 50 and 16 is? 66. I thought it was 76 because it's the morning and I'm not awake yet. Let's see, I can also add up pretty easily 16 plus 48. 64, good. Now, how do I get this one? Yeah, so we have a total. Yeah, we need to subtract part of it, so that would be 86. 136 minus 50 is 86. And then, of course, I can also total both directions and make sure they should work. That makes sense. 200.
Oh, wait, I didn't, never mind.
Yeah,
no,
200.
200.
Okay. We can also create what's called a relative frequency table, but we're not going to bother with that because it's unnecessary. But we will be completing tables and answering questions about tables, which is pretty easy reading. All right. So turn the page. So using probability with two-way tables here, you'll notice that this table, what's missing in this two-way table? The totals, yeah. Totals are really, really useful. And so if you are presented a table like this that doesn't have any totals, I would suggest adding them on. And so I'm going to squeeze those in right here. 62 and 20 is 82. God bless you. 28 and 15 is 43. If I add across, 62 and 28 is, I don't know, guys. Help me out here. 90? All right. Bless you. And then 20 and 15 is 35. And just double checking 125 for both of them, yeah? Okay. All right. Did we add correctly? Because that's really important.
Yes.
Okay. All right. So it's really a good idea to have a total, because if we want to do probability, remember, probability of some event is what we're looking for, what we want over the total possibilities that we have, okay? What we want over the total. So students in band were asked if they rented or owned their instrument and if they practiced at home, which I think is a very interesting question. I own a piano, a saxophone, a guitar, a ukulele, a clarinet, recorder. We got a lot of musical instruments in our house. Do they get played? No. Yeah, they're decoration. The guitar is really cool too. It's a blue tar. It's blue and kind of like peacocky blue. It's really cool. It's called the blue tar. All right, here we go. If a student is chosen at random, find the probability. We want to find the probability that a student does not practice. Very good. So the probability is how many kids don't practice? Well, all the don't practices are 43. Those are the winners out of the total students, which was 125. And I'm just going to leave it like that. I think most of the problems in Delta Math, you can just put in a fraction. Maybe you'll need to math frac. Maybe. I don't know. But a fraction is great. All right. It tells us everything we need to know. All right. What's the probability that a student practices and rinses their instrument? 62. Yeah, so practices and rinse, that's 62 kids. So 62 out of 125. And again, that could possibly be reduced. Maybe not. I don't think so. That's fine now. Okay, now, this is new. We skipped this lesson. This bar right here is the word given. All right. And so over here on letter D, rinse, given that they already practice. Okay, so this is what is called conditional probability. And all that it says is we want to know the probability that a student does not practice given that we already know they own an instrument. That's what this is saying. So, given that we know the student already owns an instrument, how many students already own an instrument? How many students own an instrument? 35. 35 students own an instrument. So this is the group we're thinking about right now. We're not thinking about all the students. We are simply thinking about the students that own instruments only. Okay? So how many then do not practice? Yeah, so this is going to be 15 out of the people who own the instrument. So you can kind of imagine that that bar is sort of like giving you the fraction, numerator, denominator, all right? There's a much more complicated way of doing it, but if that's just thinking a little bit, it's not bad, right? Okay, so what's the probability that a student rents an instrument given that they always practice? So how many students rent? 90. Okay, but given that we already know that it's a student who always practices. So what is the group that always practices? Over 82. So that's bigger than 1. So that can't be right. So how many kids always practice? 82. 82 kids always practice their instrument. So how many of those kids rent? 62. Oh, so we're really only looking in the given that they practice column. Okay, so 62 rent out of the 82. All right, so 62 out of 82. All right, we'll keep practicing with that. That definitely reduces, this definitely reduces, but you can math frac that. That's pretty easy. All right, let's look at number 5 here. A test was given to 3 classes. The results of the test are shown below. if a student from one of these classes is chosen at random, find the probability. What's missing in our the totals? So again, I'm going to write those in because those are really, really helpful. So, 19, 24, and 21, 64? Is that right?
Yeah.
Okay. 3, 8, and 5 is 16. Okay. And then the total this way, 19, 20, 20, 22. 24 and 8 is 32. And 21 and 5 is 26. And the total, 70, 80? Damn, that was some good math in my brain.
You did good.
Yeah? I thought it was pretty damn good.
That was good.
Okay. Okay. All right. Addition is hard, so. Okay. So what is the probability that a student chosen at random is in Class B?
32 out of 8.
All the Class Bs are 32 out of 80. Very good. 32 out of 80. That does reduce, but we're just going to leave it like that for now. All right. The probability that they are in Class C, oh, this is interesting, or Class C, or they passed. Hold on.
21.
Or means adding them together. All the winners we're adding up. So in Class C is 26 kids, or they passed
20 or 24 or 26 out of 64, or is it?
Isn't that 64 plus 5? Are we throwing in the kids in Class C that are in pass?
Yeah, 64. Oh, 64 plus 5, sir, is correct. All right. So or means either or. There's two groups of winners here, kids that are in the Class C and kids that passed. They are both winners. All right. So how many kids passed? Yeah, 64. All these kids passed. So there's 64 winners there. And then in Class C, how many kids are in Class C? 26. However, what's the issue here? We already counted the 21. So we don't want to count them again. We don't want to count them twice. Does that make sense to you? So who else needs to be added in? The 5 right here. So we got these kids all passed, and this extra group is also in Class C. Does that make sense to you? Okay. So there's a 5 extra there. And we could count it different ways, but the trick is we don't want to count people twice, because that would not be accurate. Okay. So, or we're just adding the groups together, but we don't want to double count people. All right. Does that make sense to you? Okay. So 69 out of 80 kids. And again, if we counted them twice, all of these groups and this group right here, if we counted them twice, our probability would be bigger than 1. And that cannot be. All right? Despite what Trump believes. Cannot get over 100%. Okay? Doesn't work that way. Okay. All right. So down here, what does this bar mean? Given. All right. Here we go. Given that we already know that a kid is from Class A. So which group am I looking at? Just the total of Class A. That's right. So given the student we know comes from Class A, so that's 22 kids. How many did not pass? 3 out of the 22, okay? So that given just focuses in, what are we looking at? Okay? So the probability that they're in Class B, given that they passed, what group are we looking at?
B.
Just the passed. And how many kids passed?
24.
64. How many were in Class B? 24 out of 64. That reduces as well. So again, that given, all it does is just limit, hey, I only am looking at kids that pass, so we can ignore the other data. All right? Does that make sense to you? That's conditional probability. So the condition is that they were passed. All right? So that's just using your brain a little bit. Okie dokie. How are you feeling about that?
I think we're ready.
Are you pretty good? Yeah? All right, I think you're good too. Super. Hey, congratulations.